Hi, hello everyone. Myself Orko Jyotide, and today we are going to solve a medium level question from LeetCode, that is count good numbers. I have chosen this question because it is related to one of the question from the recent contest, that is count the number of arrays matching k adjacent elements. It is a hard level question, so before solving it, we should it's better to solve a medium level question that will clear up much of the concepts, right? So, and we will be introduced to modulo in this question as well. So, those who know, good, but those who don't know what is modulo, how to do it, or how it actually works, this is a very good question to get introduced to the concept, right? So, what is the question? A digit string is good. Good. Okay, we need to check. Okay, a string will be considered good. Humans are unable to be good in this era, but a digit string can be, according to LeetCode. Okay, let's proceed to the question. Can be good if the digits index at even indices are even and the digits at odd indices are prime. So, uh, here an example is given 2582. This is a good string. Why it is considered to be good? Because at the even indices it should be even. Okay, let me draw it for you so that you can understand a little bit better. 1 2 3 4. Okay, in the example, it is a n of length 4, 2582, right? 2582. Okay. My handwriting is awful because I'm drawing it with mouse, not a drawing pad. So this is zeroth index, this is first index, second, and third. Has there they have mentioned that zeroth index? Yeah. See here, it is mentioned that we will be considering zero-based indexing, right? These are the small things that you need to focus. Otherwise, your uh, complete logic will be a mess. So what? So what you can see at the even indices. So what are the even indices? These two are the even indices, 0 and 2. And what are the odd in? Okay, let's talk about the even indices first. At the even indices, we know that the digits present will be even. Okay, 2 is even, 8 is even. At the odd indices, we should check that the digits must be prime. Prime, okay. What are the digits that can be prime from 0 to 9? It can be 2, 3, 5, or 7. And you don't have to, um, if you don't know it, no problem. Here it has been already given 2, 3, 5, 7 are the prime numbers, right? So, 5 is a prime at odd index, and 2 is a prime at the odd index. So, this is good according to the question. And suppose, okay, now zoom in. Okay, done. So suppose, and what is a bad? 3245. 3245 is a bad string. 3245. 1 2 3 4. Indexing 0 1 2 3. So this is a even index, and oh no man, they have placed a 3, and at the even index you should be having a even digit, so it can never be a good string. So is this written? because 3 is at the even index, right? But it is not even. So what actually the question wants us to actually solve? You will be given an integer n and return the total number of good digit strings of length n. Okay, so we will be given a n and we should check how many good strings are there. Since the answer may be large, return it modulo 10 to the power 9 plus 7. Okay. Uh, for a little bit of time, let's ignore the modulo part. Let's actually understand the question, that what it wants from us. So if I talk, then we will be given a n length, and you should return how many good strings are possible. So this is the zeroth index: 1, 2, 3, 4, 5. Okay. So can you think it like this, that at the zeroth index you can place how many numbers you can place? What is the how many numbers you can place? You can place 0, 2, 4, 6, 8. So 1, 2, 3, 4, 5. You can place 5 digits, right? So it has 5 possibilities to be placed. But hold on, am I doing some mistake? Because at the first position, the if we place 0, then it is senseless, right? But no, hold on, because if it is given in the question that the string will consist of digits 0 from 9 and it may contain leading zeros, so we don't have to think so much about the first position. You can place a 0, so there are 5 possibilities. At the first index, how many possibilities are there? It should be all the prime digits. And how many prime digits are there? 4 prime digits are there, right? So 4. And again at the even index, 5 possibilities are there. Here 4, here 5, here 4. So can you sense something? That if n equals to 1, 2, 3, 4, 5, 6, then the result that we require is 5 to the power 1, 2. And we know by probability that all those should get multiplied, right? So 5 to the power 3 and 4 to the power 3. uh okay, can we arrive at some formula? Because if we will if n is given and we will iterate from 0 to n minus 1, getting all the indices, and if we will multiply it, if it is a even index, multiply it with 5, if it is a odd index, multiply it with 4. It is a brute force or most naive approach, and it will consist of big of log n, sorry, big of n time complexity. So can big of n time complexity work in this question? So let's take the constant. No, look, the constant is 10 to the power 15, and we should solve it nearly around 10 to the power 7 to 10 to the power 8 to make it work. So what we can do, so here you can see something, that you can't iterate from 0 to n. You need to find something like root over of n or logarithmic of n solution, right? Okay, understood. But here look, that okay, can go that side. That side, a lot of space is actually vacant. Okay, so you have um, checked that. Suppose, can we get some formula? If n is equals to 1, it will be 5. If n is equals to 2, it will be 5 to the power 1. 4 to the power 1. Into is always there. Okay, if it is 3, it will be 5 to the power 2, 4 to the power 1. So can you sense something that the power of 4 is always n by 2, and whatever is left from n, if it give n by 2 to 4 to, okay, I'm telling n is given to us, I have done n by 2, and I will say, okay, n by 2, go with 4. You need to be the power of 4. So what am I left with? I am left with n minus n by 2. So n minus n by 2, you become the power of 5. Okay, so it will go with 5 and it will go with 4. Is it working? If n equals to 1, n by 1 by 2, 0. See, here 4, here nothing, 4 to the power 0 is there, right? N by 2, okay, done. N minus n by 2, 1 minus 0, 5 to the power 1. It is working. For n equals to 2, n by 2, 4 to the power 1, n minus n by 2, 5 to the power 1. For 3, 4 to the power 1, n by 2, and n minus n by 2, 5 to the power 2. Okay, 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 it's working. So let's take a big n, and now n will be how many? 1 2 3 4 5 6 7 8. Okay, 8. 8 means 4 to the power 1 2 3 4, 4 to the power 4 into 5 to the power 4, it should be there. N by 2, okay, n minus n by 2, okay, done. So our formula is done. So you will say, by using this formula, you can directly return that what you need to return, right? You will do math dot power. You will use some power function, either it is in Java or in C++. Everyone has a standard power function, right? And you will return, but we can't. Here is the crux. It will be big of n, right? So no need to worry about the constants. But no, as the answer may be large, we need to return it with a modulo. Here comes the crux that makes the question a medium level question. So what we need to do is, let's go, to make it a little bit bigger, and if we zoom in, we will get some space, right? Okay, so what I can say is, what I'm talking about, okay, the modulo part comes in right now. So you have got a very good formula, that is 5 to the power n minus n by 2 and 4 to the power n by 2. But you need to do the modulo, right? Modulo means, see, if I have got a, a very large number, suppose, okay, I have got 49. If I do it mod 7, doing it mod 7 means my number, I if I modulus any number with 7, I will get a number between 0 to 6. So we are moduling with 10 to the power 9 plus 7. So as we are moduling 10 to the power with 10 to the power 9 plus 7, then we will get something, we will get the answer ranging from 10 to the power 9 plus 6. This will be the range of our answer, and it lies within the integer range. So we can return it, as the range can be large, as the answer can be very large, and we are given a function to return int, I guess. Yeah, see, we are given a function to return integer, so we will to a modulus with 10 to the power 7 plus sorry 10 to the power 9 plus 7 with a very large prime number. So we have got this formula, but how to implement this? How to, because you are every time you are multiplying with something, you need to do a modulus with the mod value. But if you need to do every time the mod value, every time you multiply with something, you need to create your own power function. And if you want to create your own power function, then it would take some time. But the constraint is very large, 10 to the power 15. So let's think, how can we make a power function? So our next problem is making a power function. See, suppose I give 5 into 10 to the power okay, 5 into